Good morning. I'd like to thank IISc for this invitation, and it's great to be here in an academic setting and in a place where I enjoyed always coming here. I worked with many of the IISc professors, many of my engineers whom I worked with for over 20-30 years are from IISc, some of the brightest minds that you can find in the country in any engineering institute, and it's been a great pleasure to create products along with them. So I don't have slides, so this takes a lot of time and effort and a lot of clearances from industry to present anything outside. So if I have to prepare 100 slides, it goes through 3-4 approvals and why this, why not this. Finally, slides doesn't have any access, doesn't have any numbers. Anyway, it makes no sense. So I stopped making slides for quite some time. So I would like to talk about the challenges in creating an EV ecosystem, right? And so this is the biggest thing which is going to happen in the next 10 years, everybody is doing, and we heard a professor talking about the fire instances which we went through, and professor was there as a part of an audit committee, and I was new in Ola, I just joined 1 month later, an incident happened, right? So anything we produce, we are humans, we tend to produce things with flaws, and there is nothing called perfect in engineering. You take any product, you turn it apart, and any appliance you have, a cell phone to a microwave to anything, you use it for some time, you open and see, you will be surprised to see how bad the engineering is, right? And it doesn't hurt you, but they are engineers, right? There are engineers in every company like you, and working, creating products, and without really understanding how long, how well, how bad it will be used by the customer to whom we sell these products. So I'm going to talk about the challenges in the EV, in creating an EV ecosystem, and Ola is on its journey to create one of the finest ecosystems, and in the next couple of years we will accomplish what we set out to do. Maybe that will create a kind of a nuclei to create talent and create capability in the country and for the country, and like Bhavesh always talks about, made in India for the rest of the world, right? And we are here to create. So we have 3 challenges. The first and foremost challenge for a EV ecosystem is people, right? You and me. And where do we get them? In good institutes. But how do you get them? How do you retain them? How do you get the skills? So we have talent pool is the biggest crisis in the industry, right? And so I look after engineering for Ola, the entire engineering of vehicle development. I don't look after the cell related activity. There's a massive research group in Bangalore, and if you have an opportunity, please go see this, one of the finest chemical engineering research groups for cell research. Variety of chemistries for NMC, LFP, solid state, sodium ion. So it's located in a nice electronic city. It's a wrong place to see a chemical research group. It's a hazardous area certified. Battery of electron microscopes and whatever spectrum analyzers, you analyze, characterize material, and you abuse, test. So the cell is getting ready. Ola will make its own cell, and so researchers are required. There are 350 researchers, PhDs working there, headed by the ex-CTO of LG. He's a Korean and PhD, and he leads the research for us in the cell research. So I lead the automobile sector of the company, creating products. So the first and foremost challenge is getting the best talent to create an EV ecosystem, be it power electronics and be it the regular embedded electronics of size and shape what we want, and creating the batteries and battery packs, as we call it in a vehicle. We buy cells. Today we buy from LG, millions of them. Ola is one of the biggest customer for LG in India, till we make our own cells, right? So we will be buying, last year we bought about 12 million cells, and it's a huge amount of cells, and every battery pack in Ola scooter has 224 cells, and they are put together in a nicer way, and everywhere there is a skill involved in creating. Like I would like to start with the battery pack and what technology goes into this. Professor Subba Reddy came to see our line, and 224 cells connected, 16 in parallel and 14 in series. 16 of the sets connected in series to create 52 volt system capable of giving close to 200 amperes as a peak current, 220 amperes as a peak current, continuously capable of giving around 75 amperes. Now this pushes to the limit of everything, right? I have to collect current from 16 cells and through a system which is very unique. Ola uses a system called wire bonding. We don't use welding, we don't use spot welding, laser welding. There are many ways you can join a cell, but we use wire bonding. So wire bonding, you just keep an aluminum wire on top of the cell, keep vibrating with ultrasonic till somehow the molecules find each other and connect each other. It's a very strong bond. The wire is microns thick and it can carry 18 amperes of current. It can carry a load of around 1.8 kgs. So it looks very tiny, hair-like wire. The technology doesn't exist in India. See, we got all these machines from Germany, and it's a very simple technology. You have a pointer and it presses against a wire against the cell, just vibrates at kilohertz. And at some point the molecules, enough heat is generated in that point where we create the vibration. These machines we have 30 machines making these joints, because 224 into 2, 448 joints per pack. And it's the beauty of this is it works as a fuse wire, right? When you have a thin wire, it collects current. The cells have a very nice behaviors, right? Internally it can get short. When we investigated the fire in Ola vehicles, and we eliminated everything. So one by one we checked, and finally we found nothing could be proven. You short, the BMS will remove any dead short. You take a battery pack, fully flowing with the 200 amperes current, connect a copper rod and short the output, right? So you will exceed the discharge current rating, so you will have an internal resistance of a cell. All of us know how to calculate the losses for a resistance when current flows, and that much heat can it be dissipated in a cell, and that dissipation doesn't happen. Everything, electrolyte, which is a nice organic material, evaporates, and there is a venting system which comes out like a plasma and can catch fire. So to do that, you do a short test, and the BMS is very sharp, right? We have MOSFETs which can switch in microseconds, and they detect the short. We have a current sensor. It's a simple analog looped tripping system. We trip the system to protect. So you can never short these battery packs. Now, why battery packs goes into runaway? Most of the cases there is a manufacturing process. Like we said, 9 million, 10 million cells. You go see these lines. In a minute they produce thousands of cells. You roll copper and aluminum foils coated with materials in a few seconds, and then insert them into a steel can. Now you have positive, negative there, so you have to join to the ends of the cell. How do you join metal to metal? They don't use ultrasound. It's too slow process. They all use spot weld or laser welds. And we all see when we cross in the roads, people doing grill work and welding work, you see a lot of sparks fly. We think it's a nice spark, right? They are not sparks, they are iron particles which nicely fly. When they cool, it becomes a nice iron piece. And because when you talk in micron scales on which these cells are wound, there is a plastic membrane separates positive to negative, keeping the 4 volt away from each other with a ton of energy between 2 plates, and this iron settles down in the plastic. It's a very innocent looking iron particle, part of the welding process. It should not happen. There are enough vacuum suction processes the cell companies use, but the cells go through an expansion. We use a cylindrical cell. When you draw current and this thing, the material in the anode cathode expands, the volume of the cell increases. So now this is wound as a spiral, so you have a metal particle sitting in between anode and cathode plates, and in the plastic it can puncture. When you have an internal puncture of a cell, you have so much of energy ready to get through the positive plate to negative plate, and then the energy can't be dissipated because it generates as a heat, and that heat makes the electrolyte vaporize. You heat the electrolyte beyond a point, it nicely becomes a flame torch and it can come out. Now whenever the short happens, we have another problem. We have 16 cells parallel, right? We have one cell which is bad, which got shorted, whatever the reason. Other cells try to dump the energy stored in them through the welded joints because they are parallel, and this cell has to dissipate now 15 cells energy in a tiny piece. So the amount of heat you can calculate, very simple thermal, right? and we call it thermal runaway. Everything goes out of control, the temperature is high, every cell heats up. So when we did this, now there is a regulation, lot of questions on the regulations. Very tough regulation. What we do is we put a heater on a cell, heat it up to 300 degrees, and the cell goes to vent. And when it gets vent in today's packs, what is produced from April 1st in India, you can heat any cell or overcharge any cell, make it go to thermal runaway, either it's a pouch cell, cylindrical cell, or any form of cell, either a scooter or a bus or a truck or a car, and the runaway never affects the next cell. It's a beautiful way of doing things. We use polyurethane, or somebody uses some other material, people use phase change material. Lot of technologies, all the engineers here know what it goes into creating different material. You have a cell wall reaching 400 degrees. The next cell is within 2.1 millimeters. That doesn't reach beyond 60 degrees. Right? We keep, earlier this was not there, the regulation mandated this process. Every one of the companies meet. So we would have done about 500 to 600 of thermal runaways. You create a single runaway. Yesterday we did 6 thermal runaway for a new material evaluation. We are looking at how do you create this barrier between two cells, but also you remove the heat from the cells to keep the cells cooler, right? So there is a now let me finish, questions will come to later. So we have a thermal runaway. It's a big issue. It's a thermal problem, it's an electrical problem, it's a manufacturing problem, right? It's a prevention problem, right? You assume worst case it will go to runaway one cell once in a while when you produce millions of cells or billions of cells in future, and when it goes, the customer should have the vehicle intact. The cell going runaway, cell can go bad, the energy has to be dissipated. The energy can't be used to create other cell go bad, the good cell which is working perfectly. So the system is in place today. All of us know how to do it and learned how to do it. Every company we have a couple of patents. How do you do? The cost at which you do. The battery pack is the costliest equipment. So you do at a very expensive. Phase change material is very nice, and polyurethane is very nice. People use different materials. So you have a technology of electronics. So when I talk about people and skill sets, this is what complicates the whole thing. To design a battery pack, I need a mechanical engineer, I need a plastic engineer, I need a bus bar aluminum electrical engineer. I have to have, because I have a bus bar which is 1 meter long, when I switch and on and off, that nice looking aluminum rod becomes an inductor. Very nice small inductor. You know, whenever you disturb the energy in an inductor, and it creates nasty voltages. The electronic doesn't like voltages which are beyond their capability. They are all connected to very sensitive measuring systems. We have a 16-bit, 22-bit ADCs to measure the voltage, so that we have an accuracy of voltage to measure calculate the state of charge. So this is the measuring with the separate instrumentation grade amplifiers. We measure the voltage, we measure the current coming in and out of the battery packs. We have an electronics which prevents to short circuit or disconnect or connect. And this is supposed to protect. If the battery is full, it doesn't allow charge to happen. There is a protection on charging so that the overcharge doesn't happen. That's also part of the regulations for safety. And this electronic has to be designed. It has to be compact, small, fit inside a battery pack, sit and work in the temperature of the battery pack, and protect the battery pack. Measure. So there is a compute and there is a protection systems. The compute calculates the SOC, SOH, how much is degraded with the number of cycles, and cells age, calendar aging is a big problem. Many of our customers, we are given the biggest pack to avoid range anxiety, 4 kilowatt hour, it runs for 200 kilometers. I have a friend who is a professor in Sri Ram College. He talked to me, interviewed me for 3 hours before buying his Ola scooter. And he asked what is the range, how do you do, what is the calculation, how the battery, what is the cooling, what is the motor, what is the type of motor, magnet. Finally, I convinced him to buy a scooter. So he lives in SRM campus in Chennai. He drives the scooter, and he called me 1 month later. He made a list of observations on the design, vehicle, everything. He said everything okay, how he feels in a speed breaker. And he said, your range, what you told is wrong. So I'm getting lower range. I said, how do you drive? He said, I go from my hostel or campus quarters where I live with my family. I go to my lab where he does, he's an automobile lab head. So he is a professor there, so it's 2.8 kilometers he drives in the morning, and then comes back for lunch, and then goes back, and again comes back. So around 10 kilometers a day, and he ends up using it for around 25 days, almost a month. He charges once in a month, and he found what we advertise as 190 kilometers, he is getting 170 kilometers. He is very upset, he lost 20 kilometers. So I have to explain to him there is a natural thing. You don't do anything, you keep your vehicle, end of 200 days your battery is empty. What happened to all the 4 kilowatt hour or 4000 watt hour of energy you put inside? The cells have a leakage path internally. I had a hard time explaining, got all the research articles, papers, books, typical of a professor to get convinced. Yeah, I gave all the material. Finally, now he's convinced 20 kilometers. So if I don't use, I lose energy. So he was coming with the theories, can I disconnect and keep? You can't disconnect because the plates are close to each other in micron gap. They leak electrons, doesn't like to stay excited. They move across. So the battery has a technology which is very complex. We see this happening. We are now going into Ola is making a 4680 cell. It's a bigger diameter. We are using 21. 21 is a 21 millimeter diameter, 70 millimeter height. Ola is making a 46 millimeter diameter and 80 mm height, bigger cell. We will have 200 watt hour of energy per cell. It's a huge energy. And these cells will be connected again series parallel, right? So we will have enough cells in a pack. In a 4-wheeler pack, we will end up having close to 75 kilowatt hour. Ola is making a car. We are designing a battery pack to go into that. It's operating at 800 volts and it's going to have a energy capacity of 75 kilowatt hour for a customer. Normal, the lowest version, which I think we all can afford, is a 50 kilowatt hour pack, going up to all the way to 100 kilowatt hour. It's a ton of energy in a cell, in a battery pack. The technology of manufacturing, the technology of wire bonding, we don't have a wire bonding technology. We don't have a technology to make good quality electrical grade bus bar. We don't have a technology to have a single MOSFET high current module or a SiC module, very compact module. So currently I use 12 of them in parallel to get the current of 220 amperes continuously without increasing the temperature. And we don't have people to cool. Since it's an academic, I can share some fun things. Electronic engineers and cooling doesn't work together, right? They think bigger fan cools better. They think somehow water nearby cools better. They think touching with other something called fin, aluminum fin, will cool better. But the fun part always happens is how do you touch a MOSFET body which is carrying a voltage of very high level with an aluminum part. Now comes the fun, right? Put a thermal pad. So you have a heat source, you have a heat sink in aluminum, thermal conductivity, all of you know what is aluminum. Now you have a dumb plastic in between which has 1/100th of the thermal conductivity of that aluminum. And they swear that heat goes through that path and reaches the aluminum. I swear them that it never goes there, right? You can have a wooden piece, I will prove that wooden piece takes the same heat. So there is a huge dearth of talent in thermal engineering. I was reviewing a paper last week from China on a thermal modeling of a motor, 6 methods, AI based, lump model, standardized model, simulation. He has validated all 6 methods and proved which method. His AI model is beautiful, 1.3% accuracy on the copper wire tip. We take a U-turn in motors, in the copper wires are wound through the lamination. It is floating in air at some point, right? I have to take a U-turn, make another winding. This turn which happens in air has nowhere to dissipate heat. I have an iron removing heat. I have other places there is a removal of heat, but the copper wire hanging in air, it doesn't have anywhere to dissipate heat. It heats up like mad. And we all have temperature sensor only in the floating copper so that the copper insulation doesn't burn off and we had a short in that. So thermal science is a nightmare in the way thermal engineers, they feel that they don't understand electronic junction temperature, how do you create heat in a MOSFET. They don't understand why a cell is getting heated up, how the heat will come. The constant fight between a thermal engineer and a cell guy saying heat will come through the side on a cylinder or through the bottom of the cylinder, right? It has to come out. You try to measure it where it comes out, right? You know the internal resistance, you send a current, you see the heat loss. So thermal science, all of us learn in multiple ways. We have beautiful departments, modeling capabilities. Do we have it to the level of accuracy what we want, right? And where do you use the heat transfer path, what happens to the thermal interface materials, what industry sells. This is a ton of price. I get an aluminum cheaper than a thermal pad from 3M, which is costing 3 times the cost of a MOSFET, of a single MOSFET to remove that heat. Actually it doesn't remove, it's an insulator for me, and or a thermal barrier I will call it. The 3M guys will get very upset when I call it thermal. They sell it at a huge price. So thermal engineering is a huge challenge for the industry. We don't have the engineers who like electronics, like cells, who solve cooling problem. I was suggesting to because we are designing cells, we end up in reviews with the cell team. I was telling them, why don't you make your casing with a lot of fins? You are making a tubular cylinder, put your jelly bean of anode cathode inside. Why don't you give me some fins in the casing? He said, you design a casing, I will make it. Because I was curious to know how to dissipate the heat from that. So there are a lot of patents. Our teams have filed a lot of patents. You will see some of them. One of the published patents is we have a hollow cell. The center core is hollow. There is a tube. We can pass a liquid and cool the cell internally, which is a very novel idea, right? So it was done by a young student who is an engineering college student from Bangalore who joined us. He always was curious. He was talking about it. We said it's a very good idea. We filed a patent. We don't know still how to connect the plumbing to each cell. It's water near the cell is a danger item. And another thing which India always lacks is how do you seal things, right? And it's a nightmare to seal. Everywhere we go, you have a rope and a white color paste in all our plumbing. Wherever it leaks, tighten it more, 2 more threads, right? It's supposed to be a taper thread. It's supposed to seal itself. You ask anybody who teaches sealing in Indian academic institutes. Nobody teaches sealing. Who does the simulation for sealing? Nobody does. We talk about hydrogen now, the beautiful gas. And how do you seal this dumb gas? You can't seal hydrogen. You try to put O-ring, you try to put pressure, you put a taper thread, you tighten, apply force, white paste, color paste. It doesn't stay there. It leaks all over the place and you can't see the leakage, right? Till you have a flame burning in a colorless way. So we have a lack of capability on sealing. I have to test. Last week I finished my new pack underwater. You would have seen videos of Ola scooter going in a seawater in Mangalore. The customer was a crazy guy. Half the part got corroded completely after a week of his experiment. We have to sympathetically view him, give him a vehicle. It survived, right? So you would have seen the video. It's a real scooter, customer scooter. He paid for it. And after he published, all of us were surprised. We never designed a vehicle as a submarine to go underwater, that to seawater. And he was happily driving, paying 1.5 lakhs for a vehicle and drive through seawater. And park the vehicle, your vehicle is gone. Every part gets terrifically corroded. And the battery pack we recovered from that vehicle, absolutely no water inside, right? So sealing is an area we lack as a capability. It's a beautiful area. Sealing in the battery pack, water can't go in. Sealing in a motor, water can't go in. I have to cool all these areas, but I have to avoid leakage. In the Ola vehicle, we have an air-cooled motor, but it's cooled. We have a air-cooled battery pack, it's still cooled, right? I had a huge argument when the fire happened, when the professor was visiting, auditing. The press wrote, Ola pack is plastic and it's not cooled. That is why it happened. So we had a sad story of, I worked in Tata's for a long time. The guys who are running Tata Electric is a very close friend of mine. And we all grew up in Tata's as engineers. My first job was in Tata's after IIT. And so the chemistry was NMC for us. Ours is an air-cooled pack. Ours is a startup. So 3 acquisitions against Ola. Startup doesn't do testing because they're in a hurry to make money. Say they don't do any testing. So Ola vehicle went up in flame. We use plastic packs. Plastics are bad for heat, right? It doesn't conduct. Till I told you that thermal conductive paste story, right? And the third part is we use NMC chemistry. NMC chemistry is known to fire. Everybody knows you overcharge NMC, NMC cell explodes. You do a short circuit on an NMC, it explodes. But LFP is a good battery. Chemistry is very stable. Even though at low energy density, Tata's use LFP, Tata's use water cooled pack, Tata's use metal casing. It went up in flame, right? So the press guys said that if you use these 3, it won't go up in flame. Finally, thermal runaway is a possibility in good pack, bad pack, whether it's a Tesla, whether it is Volkswagen, whether it is Hyundai. All the companies you can read the fire incidents in thermal packs, in battery packs. So finally, the knowledge of creating a sealing doesn't exist. And when last week I got the report of 6 packs, we immersed in water and tested it for 8 hours and it beautifully survived. So, hi, I'm in a meeting in ISC. I won't be able to join, I'll join after. This is Bhavesh review in the morning. And so this is technology area. Thermal is an area we miss. Sealing is an area we miss. Power electronic connectivity is an area we miss. How do you transfer 200 amperes to the printed circuit board? It's an area. And how do you transfer this electrical energy without losses? So we had all the wires, right? Every electrical engineer here knows Dr. Subbareddy lab, I went and saw this beautiful corona and high voltage connections. Everything, there's a nice copper wire. Then there is something called terminal which we crimp. And so you put a copper thing and crimp it nicely with the hydraulic crimping machine. I go measure the resistance, it's a nice milliohms. You have 200 amperes, multiply. You have a good amount of loss in each of the crimping. And when you make a high voltage system and high current system like electric vehicle, every crimp joint we lose energy. So the efficiency of the vehicle, the energy out of the battery, as I bring the energy from cells into the outside world, connection to the power electronic system, inside the power electronic connecting the current, there's a huge loss of efficiency simply because I waste energy. Instead of sending it to the coil in the motor, I waste in the connections in the motor, connections in the power electronics, connections in the battery pack, every wire carrying. There is a better way to connect. There may be a better way. There may be a better way of joining a bus bar or a copper wire to it's a terminal block, but still we don't have engineers to design. I was trying to design some of the crimping tools to whenever we see inefficiency, we try to solve it, right? So how do you design a crimping tool which has lower resistance? How do you see the copper deforming under compression? It's a beautiful topic. So how much pressure is required to make the cylinder circular section copper wires become into something where I have a plastic deformation so that I have a lower resistance path? We asked somebody to calculate, model the whole thing, but it is still a loss. For an electric vehicle, I was losing almost 8% in losses in the joints. From the cell all the way to the motor copper wire, I've lost 8% of the energy simply because because this is an electrical part. The drawing is made by my electrical team who doesn't care about the losses in the mechanical crimping. He doesn't understand what is crimping, why you crimp. I don't know it's crimped. It's a supplier is crimping, he has a tool. No calculation of any of that, because these methods are made for a world where energy was almost free, and on a vehicle energy is not free. If I can save 8%, the customer can go 8% longer distance. I win the race, right? So my vehicle will have a longer range. So the efficiency of systems, thermal or sealing or losses in conductivity, in joinery, in putting modules together, managing their behavior, all are adding thermal signature. When I have losses in my electrical connection in the battery pack alone, I have a 2% heat source is nothing but joineries inside a pack. So all of them are producing heat, and I have no way of removing the heat easily because it's produced in so many distributed ways. So now leave the battery pack. It's a set of technologies. Is India has all the skills required? Our institutes provide all the skills? Yes, they have, but in pockets of excellence. I don't have it in an engineer. If I have a battery pack team, I want a guy to be good in sealing, good in thermal, good in packaging things, good in joinery, good in understanding losses, right? So they don't exist. So they don't have. So we have an internal systems to cover up for the losses. So the skill in battery pack making, we are going to make a 100 kilowatt hour battery pack, which is a nightmare to make. So many connections, joints with the cylindrical cells and cooling of the cylindrical cells. We are still evaluating what is the best method to cool. So comes the motor, right? Another misunderstood item. It's been there for last 200 plus years. You put a magnet, you put a copper current, it beautifully rotates. Now the problem starts, right? I have to import tons of magnet. I'm importing all the magnets from China. We have a line producing. This is only company which has a motor line inside the plant. In Ola factory, when professor came, it was not there. Now we have a line which is capable of producing 1 million motors per year in the plant. Like companies produce million engines, we produce 1 million motors in the company, but all of them are rare earth. So rare earth comes from China. So the magnet is the most expensive item. The cost of the motor can be brought down by 30% if I simply have the magnet-less designs. I have an EESM design. I'm doing a reluctance, assisted reluctance designs, trying to evaluate. EESM has a problem of rotor cooling, and how do you cool rotor, and how do you seal rotor cooling. We have two problems, right? India is bad in cooling, India is bad in, Indian skill sets are bad in cooling, bad in sealing, right? I have to send a coolant through a rotating part. Even a stationary part I have leakages, rotary part will leak all over the place. So Tesla did it in their induction machine and failed miserably. The same problem, how do you seal in a rotating shaft at 8000 RPM, how the seals work, what are the life of the seals, right? Now we are looking at multiple topologies for motor without magnet. We will come back in about 2 years time, magnetless design made in Bangalore, will be productionized in the same line, capable of producing from 2 kilowatt all the way to 53 kilowatt in the same line, same frame size, and without a permanent magnet. So this is another area how the electromagnetic thing works. Whenever you see a 0.4% loss, we were trying to remove. We made two motors. One motor had a less than a percent loss. So I was asking, we repeatedly made this assembly in the same line. We tried to find out. You have the tools to measure losses in a motor. It doesn't exist. We measure current, voltage, and we have a dynamometer to measure the power and torque. And it doesn't give you the losses in the bearing, losses in the seals, losses in the electromagnetic variations, the field, the losses in the core, the steel, the lamination, their stacking, the edge leaking of the flux. All of them are trying to quantify. So we are operating around 92% the peak efficiency. Most of the places 89%. We are trying to improve the design to take it to 95%. People, I have seen a research paper in Sweden, 97% efficiency, motors with permanent magnets. So there is huge opportunity to work in motor, and motor also carries the same problem what we talked about in thermal, right? How do you cool these coppers? I had a professor in University of Washington. So what is the state of the art in motor? So Ola motor is around 1.2 kilograms it weighs to produce 1 kilowatt of power, right? What are the best in class? I have seen 17 kilowatt in 1 kg of copper, right? And the Washington University professor demonstrated a very novel patent. You should read his patent, sending water close to, he's a mechanical professor, he's a cooling expert, and he designed a motor. He chose a very simple surface mounted permanent magnet motor, least efficient compared to our great IPMs with the reluctance torque. But that system, he made it so compact. I had a motor in his lab weighing 2 kilos, producing close to 24 kilowatt. 2 kilowatt motor is very, very small, compact. This is the size of the volume of the motor, producing 24 kilowatt, right? So this is efficiency of material usage. So the first time I learned that motor design is not about electromagnetics. We all know, I know electromagnetic engineers will be there in the crowd. And but the problem of motor design is thermal. You are the best thermal engineer, you can make the best motor in the world, right? Which is not understood. We don't tell our students studying thermal that you will be the best motor designer, because they are not in electrical department, and but they will have the potential to become the finest motor designer who knows how to cool the parts which is producing heat. You should know the basics of how the heat is produced in a motor. He is able to cool. The electronic can dump enough energy into the motor, and I can have enough magnetic flux created by the electricity. I can have the highest power density motors. So imagine a campus bus of 150 kilowatt is made of 15 kilowatt motor. It can be hidden inside the wheels. If you have a 2 kilo motor, 24 kilowatt, most of our cars what we drive, small cars in India, 4 wheels can have a 100 kilowatt system. It's hidden inside the wheel hub. Such a compact power possible, provided you know how to cool it. You don't cool it, we will end up making very nice motors, which we make them lot in Coimbatore and Rajkot for our pump sets with a 40% efficiency, right? And where electricity is always considered as free. So the motor technology, the electromagnetics, one small part, the bigger part is the cooling and thermal handling of the machines. That knowledge capability doesn't exist today in the industry, in the academics, and I've seen sporadic discussions on this, and the ability to model perfectly a thermal model which I can believe and I can trust and I can cool better. Again, this goes in hand. If you understand the heat flow, you can model it, verify your model, then you know how to design a cooling system. You think about it, where the heat is generated, you can cool it. Now comes the set of electronics what we use in vehicles. The electronics what we use in vehicles, the RF part of it, all the vehicles are connected. So we were adamant that we were getting an antenna from China. Every antenna in India in every cell phone is from China. Like every magnet in every one of our motor is from China. Every motor that vibrates our phone is a beautiful motor. If you have a time, you open and see it. It's a beautiful motor, and that motor magnet is from China. Every speaker in our cell phone which we listen songs to, they are all from China. Every earphone what we use, whatever brand we use, they are from China. The entire magnet technology, we have lost it. It's not with us. It's all materials comes from China, right? And the electronics part of the story. We integrate a lot of electronics, the knowledge to create connected vehicles. The Ola vehicles, we have around 4 lakh vehicles in Indian roads, and they pump in a ton of data into our data servers, and we have a kilometer run of 1.2 billion kilometers already. Our scooters are 15 months old, and we have collected so much of data to analyze how the battery is degrading, how the customers are using. Customers are like us, right? We want something, but we don't know how to use it. Like I talked about a professor who got a scooter who uses for 3 kilometers, wants a 4 kilowatt hour battery pack. One day when I will use, that one day very rarely comes for most of us. So everybody wants to have the best in class because we can afford it today, but they're really not getting used to that limit of capability, right? But the data tells us Ola scooters average is around 20 kilometer usage per person per day. It's very low. 20 kilometers, 1 week, once in a week charging 100 kilometers. I can survive with a 2 kilowatt hour battery pack. But customer doesn't agree to buy a 2 kilowatt hour battery pack. We tried to launch it. Yesterday Bhavesh announced the price of a S1 AR. 2 kilowatt is not there. We are ready, but customer has a huge reluctance to buy 2 kilowatt 100. In case I have a problem, one day I want to go longer distance, I can't come back home, I need to charge, right? So now the battery packs are bigger. We need to have the data pulled in so that we can analyze whenever we investigate whether it's a fire incident and why it happened, what is the ambient temperature, what is the current flow, was it self-heating itself, was the customer abusing, is there a short circuit anywhere in the system, where the overall pack temperature went up before an incident. All the data is critical for us to survive, for warranty, for abuse. We had a customer who broke his bones in Assam. 2 o'clock he had an accident and he fell down. Next day his father is a lawyer. Next day all over the place, newspaper, social media, Ola scooter, brake doesn't work. And I was almost about to die. I have injuries, my vehicle is gone. I need so much of damages. So we went through the data, we were surprised. This guy was driving in a road, narrow road in Assam, Guwahati, in the middle of a road at night, 2 o'clock. He was going at 110 kilometers in a road which is rated for 40 kilometers. And the road had 6 speed breakers. And he missed 1 speed breaker, right? And his vehicle went up in air for quite some distance and fell down. We measured the accelerometer readings. It was measuring around 20 G, right? Our human bodies are not made for a 20 G operation. So we have a problem. So he had a huge injuries. So we had no choice. We got a legal notice. He got saying that we will damage your reputation, put it in social media, our vehicle is unfit to drive. Then we have to publish all the data. We took all the data from cloud and published it saying you are driving in a 40 kilometer zone at the night 2 o'clock. You suddenly upright brake in a speed breaker. You misjudge the speed and the vehicle's ability to stop. At 110 kilometers, vehicle will take certain number of meters to stop, 30 meters to stop. And you went over the speed breaker at 72 kilometers an hour on a speed breaker, which is quite high. That speed breaker is maybe half a meter height. And that guy lost control, got injured. The data is key. How do you move data out of the vehicle very efficiently? Every antenna I talked about, like we getting it from China. We have best labs in country. IAC has some of the best RF engineers who can think about how this, I don't still understand how the waveform of my cell phone to the tower, is it a sine wave or a multi-directional sine wave? Somehow it reaches, right? We think that it is modulated. Basics we know, but we don't know why that antenna is flat on a paper. I went on dismantling an antenna, nothing is there, one copper sheet with some copper foil. Why will you pay? This is costing each antenna 120 rupees. I have 3 antennas, Wi-Fi antenna, LTE antenna, low band antenna, another band antenna, Bluetooth antenna. I met a nice professor in a meeting, right? So he lives in Madurai and his PhD research was antennas, RF antennas. I met him in a conference, I was talking to him, he said, I have a small lab doing antenna, I can help you out. I went there, met him in Madurai, he is in a engineering college, and he helped me to design. You know our antennas in Ola scooter, what we are launching, all the antennas are pictures drawn on our PCB tracks. We don't have an antenna. We deleted 4 antennas in one shot. We saved 500 rupees per vehicle. Simply because one person who knows what that antenna means, right? I was trying to see, I was also puzzled with this. Nothing is there, a layer of plastic and layer of copper. Why will it cost 140 rupees? And it is 10 millimeters by 30 millimeter length, right? It's a huge knowledge. That one knowledge of that one person, I could localize. Now my vehicle will be sold from August. Everybody will open, everybody will find where the antenna is gone. I've just drawn it on a printed circuit board and put a blue color paint, and somebody has to even have a real this thing to remove the paint to see what I have done, right? Many of them don't do it in industry. Okay, they deleted antenna. So we will come to know how we deleted the antenna, right? So that antenna is a knowledge. So knowledge was there in India in academic. Then I found out later on he is doing all the antennas for the Indian submarines. A lot of antennas he has done for ISRO. He's a specialist in antenna. So in 2 minutes he designed it. He has taken what? Some few lakhs, 3 lakhs something he wanted, and he got me 4 antenna designs, which I have just drawn it on my PCB, and it beautifully works. We check the download speed, upload speeds, and there is a knowledge, RF side. We were trying to make our own module, entire telematic module in every scooter, every telematic unit, every cell phone telematic modules comes from China again, right? There is no telematic module maker. There are 1 or 2 startups trying to do it now. US based startups, they have some engineering centers in Bangalore and Cochin. But this RF area, making our own module, our own silicon, buy a silicon from Qualcomm and make an RF design, the module design with the memory, with the capability. Another puzzle, there is not many people who can write Android low level code, right? No problem. I can talk for as long as you want. Okay, so the technology on RF is missing, technology on Android low level. All of us have phone, nobody bothers how the Android at a chip level runs, right? How it reads from your Bluetooth, how it reads from your the lower level data passing through. We are pumping so much of data through the CAN bus into the vehicle, right? And through the Android system, we have a hardware security module, we have a key system for certification, for passing the encryption key for data security. The data moves out through that thing, but still the coding, the lower end coding, we get it done in Taiwan. So knowledge, again, gap. So the capability to produce in scale is the last point I wanted to cover. Whenever you start a company, manufacture in India, so India, we have a sense of, we have a knowledge, capability to design things, we produce. We don't like a lot of money, right? So Indians tend to have hatred for money. We feel bad about earning money. You produce 10 chargers for me, that guy is very happy. When I give an order for 1,000 a day, he says, no, I can't supply. So why I went and developed a charger pin. India, pins are imported for every charging connector in India. High current, 100 amperes, through a connection, we don't know how to do, right? There's a spring-loaded system because it generates heat. When it generates heat, that cylinder expands, your electrical connection is lost. So you have a heating. It's a cycle of death, the connectors burn. Now the connectors come from China. We developed from a Bangalore guy who was doing some small connector for ISRO, and he was scared. We gave an order for per day 3,000 connectors, and now he's saying, should I have to set up a plant? I'm very happy, I don't want more money. Then we convinced him, we took him to bank to give money. He said, I have to manage more people. I said, it's good, please hire more people. So Indians are very reluctant businessmen, right? We are good, we want money, we all like one house, we don't like beyond that, right? So we want to have 20 people reporting, that is good enough, saluting in the morning, but we don't have 10 lakh people reporting to us because we are very conservative in our thought process in industrial. That's one of the reasons why our knowledge, capability never turns into product. Product production requires a lot of pain on ourselves, producing plastics, producing metal, producing tiny parts, assembling, right, and making it a vehicle, selling and seeing somebody happy. Yeah, you will make mistakes, one nut is wrong, one bolt is wrong, one part is wrong, but still it's a journey for the country. We are proud of that journey. We make products, and with engineers like you and with the academicians who help us to cross boundaries which we don't know how to cross, we don't understand many things. Yeah, all the best to you. Thank you.
Yeah, the sealing of the battery pack, right? Is it because due to a standard, or why do you actually have to seal it?
No, the water and battery doesn't like each other, right? I have a cells carrying voltage, one end of the battery is 0 volt, another end is 60 volt today. So I have to seal anyway. And if I don't seal, there is a short circuit. It's fully charged battery. If I short, it catches fire, right? Okay. I can't have internally, because it can cross my wire bond and short directly the cell surfaces. Okay. So I need to have a sealing which is waterproof. And because the battery is the lowest element for center of gravity in a two-wheeler, I can't keep it high, because when you take a turn, we bank the vehicle two-wheelers, we don't have a steering wheel. So when you bank the vehicle, if the weight is at a higher level, you feel a very uneasy feeling of vehicle tilting, right? It's a full tank driving of a bike. Those of you who drive bikes, whenever you are a full tank end of on a happy day you want to take a turn, you see the bike tending to turn more than what you wanted it to turn. So battery is the lowest point, so water will be there, you know the Bangalore weather and monsoon, we will have 1 meter, but the battery has to survive, so it has to be waterproof, and people may park in a flood water and go by the time they come back. So the sealing is very critical, we have done it. There's a 2-step sealing with rubber and it's compressed to a certain pressure, so that even half a bar pressure, which is more than few meters, it will not go into the battery even for 3 to 4 hours.
Yeah. Just one more follow-up. Are you also monitoring temperature of all of the 200 plus cells?
It is meaningless. See, never do that. The regulation says 4. We were the only company having 6. Till today we have 6 sensors. The thermal runaway, if you monitor the phenomena, you can do it in a safer place. IIC has a lot of labs. Take a cell, heat it up, it goes to runaway. Now you try and predict in your model by measuring the temperature, I can predict runaway. By the time you predict, cell is already gone.
Okay.
So this temperature sensor is kind of a warning. In case you get a warning of unreasonably high temperature, we can derate the system, reduce the current consumption, so that we are not allowing customers to drive at 120 kilometers when the temperature is hot. On a summer day, 45-degree ambient in Rajasthan, we don't allow him to drive at full speed. Right?
So,
for that we have a temperature sensor. While charging, fast charging, we want to derate the charging rate from 2C to 0.5C. The temperature goes above 55 degrees. All that we use. But the temperature sensor is not for protecting a thermal runaway, which is going to happen if something has gone wrong already in the cell.
So just to be clear, now you have 200 plus cells. So you have how many sensors?
6
do you have?
sensors.
Just 6. And these are randomly placed, or do you have some algorithm?
We have done a modeling CFD and found out where will be hot zones. We kept it on where all possibly hot areas are there.
Okay. Thank you. Thank you very much.
Sir, if you consider a motor, we have a continuous torque. So the motor dimensions are based upon the torque. So along with the continuous torque, there will be an intermittent torque which lasts for few seconds. So then which torque we have to take as a base to determine the dimensions of the motor?
I have no knowledge, I am not a motor guy. But my logic is, see, the motor size is only linked to the dimensions of a motor, is linked to only the thermal. So I saw recently one article, some startup in Bangalore has given me a coreless motor. A lot of electrical professors knows how to do a coreless motor. There is no iron in the motor, but it still generates magnetic field, right? And it's a very compact motor. He has demonstrated a 2 kilowatt motor, very, very tiny motor, without core, without iron. So iron losses are not there, but there will be other losses. So the compactness of that motor I saw in Washington University was 10 kilowatt, 12 kilowatt per kg. It's very compact. So that theories of our conventional wisdom is all I have rewritten in my mind, saying that after I saw that Swedish company's motor of 17 kilowatt per kg. So it is ultimately they are all able to cool it better. It is like server, right? Your server, data servers, all about cooling.
Maybe
Who is able to
material
cool
also
better?
plays a vital
So
role
for
in
me, the current doesn't exist in the equation. I can have a thicker copper, molded copper wire, which can carry hundreds of amperes, but provided I remove the heat efficiently, the copper from melting.
Yes. Maybe material also plays a vital role in deciding the
Yeah, but that motor,
efficiency.
the professor motor, nothing is there. Iron, copper, and magnet, nothing is there. So, but he has a very novel cooling design. Please search and read how they have cooled it inside the coil.
Is it that Ola chose forced air cooling for the battery system, or it's naturally air cooled?
Natural air cooling.
So,
See, one thing you should remember in the electric vehicle, it's full of sensors and full of computers. You have massive compute platforms, we have massive number of like 6 sensors. And it's unlike a conventional engine related concept, right? So air cooled, what happens? I know the temperature I don't allow because it's a drive-by wire. The customer opening a throttle in a car or a floor or pedal, you don't tell the motor to go faster. I receive the signal electrically 0 to 5 volt and I decide what to do based on the battery condition, based on the ambient temperature, based on the SOC, based on the motor temperature, based on whatever the age of the vehicle or a fault in the vehicle. I decide how fast he will go. He can never go faster than what I determine. Even though he has full throttle, I have a 100 HP motor, but I will give him 3 HP only because I am scared of my battery pack or a BMS says there is a fault. He has to go to service, this guy is trying to drive on full throttle. So we don't allow. These vehicles are software. So if you have a lack of cooling, you know how to operate your battery pack without cooling system. If you have a cooling system, you may operate higher. But if you don't have a cooling system, operate lower, it's safe enough.
You also mentioned the 1 kilowatt or kind of battery usage, right, for a typical consumer. Is there any consideration to actually focus on fast charging with small batteries?
Yeah, see, this is a customer psyche. See, we are engineers and researchers, also we are customers, right? As a customer, we behave very uniquely. So try convincing your son, I will give you only 50 km range, you charge frequently, you use. And he will always compare with his friend, you know, he has a 3 kWh battery, he can go to 300 kilometers. I can go once in a while to Mysore or go somewhere else, have a special coffee. Yeah, so you can't convince a customer decides buying a product, right? You can't tell a customer, you have no choice, you will have a less range, you better charge twice a day. We don't do it. So the commercial customers, bus fleet, auto rickshaw, I can do certain level of selling because your capital cost is low. You charge 2 times a day for a 300 kilometer auto rickshaw ride. I can convince the auto owner, but not a personal guy because he buys his father's money. He will buy the best if he can afford.
I have a few questions regarding the localization and sustainability and how local players can be involved in your design process to supply components that will be more affordable to the common mass. What is your thought process on that?
On the sustainability of the supply chain.
Yes.
Yeah, so we go audit and the suppliers. We have an internal audit process for material sourcing, sustainability of the raw material. Like now we are getting into cell manufacturing. We have a set of consulting companies who are going to do the audit for the lithium source. We are trying to get from Australia, from rocks, lithium carbonate. So there is a source related audit. For cobalt, we buy from a source which is giving a certificate of origin, traceability, child labor not used. There are a lot of things which goes into this. There's a team separately. It's not part of an engineering team, so I don't have the details because they are all related to somebody can trace the material used in a vehicle to a not so sustainable process. We all have an issue. So we employ the best talent for that area. They do it. We believe their method of doing. We audit it, and any doubt is there, we can always check it. But it's a process which need to be followed, and everybody follows it.
What was the design motive behind having a larger diameter single fork at the front? A little curious about that. And
see, the single fork gives you, why will you have a single, what is that called, monoshock for the rear? Everybody falls and every vehicle is monoshock for the rear, right? Why will you not ask for a monoshock for the front? Single suspension for two-sided, there is a point of tilting load. Single tube is supposed to give you best ride quality because you tune only one. I have a two tuning of two damping systems, right? I have a valve which allows the fluid to leak or not leak. That valve dimension, I can never make it perfectly right. There's two springs, even though I make in the same process, stiffness will have a plus minus, my drawing says plus minus 3% variation, it can go to 5%. So you have two systems theoretically creating an uneven damping and this thing. But mechanical rigidity capability, it's extremely good compared to say single system. Single system, nobody makes it in India for front. We ended up with a system because it's one of the most aesthetically pleasing to look at, one side of the wheel having no support, front and rear. So it was a design which we inherited. We are moving away. So you will, yesterday you can see S1R. It's sad to lose that design, but we don't have a vendor capability to pull off. I need to go for a forged aluminum. I need to go for a very solid parts of the unsprung suspension part. It requires a lot of engineering, and customer seems to be not impressed by the ride quality. You can never match the ride quality of a single versus double. Double is always poor ride quality, but customer is right. Customer wants a twin shock because he wants to have a trouble-free shock. He wants to have like his neighbor. He is not willing to do ride quality assessment, say I have a better ride quality, you have poor ride quality to a guy who is having twin suspension. So we are forced now, we are moving away from single. You will have next 1 month of time, I will see those parts. After that, it will be 1 year spare part shop. So we have moved away.